Imagine a spacecraft the size of a basketball court, spinning like a propeller through space, facing the most intense radiation in our solar system to unravel the secrets of the largest planet we know. This is Juno, one of NASA's most ambitious and successful missions, rewriting everything we thought we knew about Jupiter. Picture this. A massive, mechanical explorer, its three giant solar panels stretched wide, hurtling through the vacuum of space on a journey spanning billions of miles. As it approaches the gas giant, it must brave radiation so powerful it could fry ordinary electronics in seconds. Yet Juno persists, dancing around Jupiter in a carefully choreographed orbit, peering beneath the swirling clouds that have hidden Jupiter's true nature for centuries. What makes this mission truly extraordinary isn't just its technical achievements, but how it's transforming our understanding of the solar system's ancient guardian. Jupiter, with its colossal mass and gravitational influence, shaped the very architecture of our planetary neighborhood. By studying it, we're essentially reading the opening chapters in Earth's own origin story. Each time Juno completes another orbit, scientists receive treasure troves of data, revealing startling discoveries. Bizarre geometric storms at the poles, a surprisingly diffuse core, unlike anything predicted by our models, and atmospheric mysteries that challenge decades of planetary science theory. Before we dive deeper into Juno's remarkable journey and its groundbreaking discoveries, take a moment to like this video and subscribe to Exploring the Universe channel so you don't miss any content about the fascinating world of astronomy. On August 5th, 2011, under the clear blue skies of Cape Canaveral, Florida, a moment of scientific history unfolded. The powerful Atlas V rocket ignited with a thunderous roar, carrying aboard a spacecraft that would forever change our understanding of the giant of our solar system. This was no ordinary launch. It was the beginning of Juno's epic quest to Jupiter. The journey ahead was staggering by any measure. Juno would need to travel 2.8 billion kilometers through the vastness of space, a distance so immense that radio signals moving at the speed of light would take over 45 minutes to reach Earth from Jupiter. To put this in perspective, if you could drive a car at highway speed to Jupiter, it would take you more than 6,000 years to arrive. For 5 long years, Juno sailed silently through the void, a testament to human engineering and scientific ambition. The spacecraft didn't take a direct path, though. NASA's trajectory specialists designed a clever route that included a gravity assist from Earth in October 2013, slingshotting Juno forward with increased velocity while saving precious fuel. Then came the moment of truth. On July 4th, 2016, America's Independence Day, Juno performed its most critical maneuver. A 35-minute engine burn to slow down enough to be captured by Jupiter's immense gravitational pull. Mission controllers at NASA's Jet Propulsion Laboratory held their breath during the nail-biting orbital insertion. When confirmation of success finally arrived, the control room erupted in cheers and tears of joy. Against remarkable odds, Juno had reached its destination. What makes this achievement even more impressive is that Juno broke new technological ground as the first spacecraft to operate so far from the Sun using solar power alone. Previous missions to the outer planets had relied on nuclear power sources, but Juno's designers took a bold gamble on massive solar arrays, 3 panels spanning nearly 60 feet, equipped with highly efficient solar cells. At Jupiter, sunlight is 25 times weaker than at Earth, yet these engineering marvels generate enough electricity to power Juno's instruments as it dances around the gas giant. The timing of Juno's arrival wasn't coincidental either. NASA planners deliberately chose July 4th, exactly 5 years after the mission's launch, as a symbolic celebration of human ingenuity and exploration. Like the early American pioneers venturing into unknown territories, Juno ventured where no solar-powered spacecraft had gone before, opening a new chapter in our cosmic adventure. To truly appreciate the marvel that is Juno, we need to talk about the incredible technology that makes this mission possible. Imagine building a spacecraft that not only needs to survive a 5-year journey through the harsh vacuum of space, but must then operate in one of the most hostile environments in our solar system. This is exactly the challenge NASA engineers faced, and their solutions were nothing short of revolutionary. Let's start with Juno's most distinctive feature, its massive solar panels. Stretching out like enormous wings, these state-of-the-art solar arrays cover an area of 60 square meters, making them the largest ever deployed on any planetary mission. If you stood them up next to a 3-story building, they would reach all the way to the roof. While previous missions to the outer planets relied on nuclear power sources, Juno's engineers took a bold step forward with advanced solar cell technology. These panels had to be exceptionally efficient, since sunlight at Jupiter is 25 times weaker than at Earth. But here's the truly fascinating part. These panels generate about 500 watts of power at Jupiter, roughly the same amount needed to run a household blender. Yet that's enough to power all of Juno's sophisticated equipment. But reaching Jupiter is one thing. Surviving there is another challenge entirely. Jupiter is surrounded by the most intense radiation belt in our solar system, a hazardous zone that would destroy conventional electronics within minutes. The solution? A first-of-its-kind titanium vault that serves as Juno's armor. This radiation shield is about the size of a car trunk and weighs nearly 400 pounds. Inside this protective fortress rests the spacecraft's sensitive electronic brain. NASA engineers lovingly nicknamed this titanium box the Vault, and for good reason. It reduces radiation exposure by a factor of 800, allowing Juno to survive the equivalent of more than 100 million dental X-rays during its mission. Another brilliant innovation is Juno's unique polar orbit. Unlike previous spacecraft that orbited around Jupiter's equator, Juno swoops over the planet's north pole, dives close to the cloud tops at about 4,000 kilometers, closer than any spacecraft before it, and then flies out past the south pole. This carefully calculated trajectory serves 2 critical purposes. It minimizes exposure to the worst radiation belts, while allowing Juno to map the entire planet. Each orbit initially took 53 days to complete, though it was later adjusted to every 43 days. This means that with each pass, Juno observes a different slice of Jupiter, eventually building a complete picture of the giant planet. On board this technological marvel are 9 cutting-edge scientific instruments, each a masterpiece of precision engineering. There's the microwave radiometer that peers deep beneath Jupiter's clouds, JunoCam, that captures breathtaking images for both scientists and the public, and magnetometers so sensitive they can detect changes in magnetic fields 1/millionth the strength of Earth's. The gravity science experiment uses subtle changes in Juno's radio signals to map Jupiter's gravitational field, revealing the planet's internal structure with unprecedented detail. Perhaps most incredible is that all this sophisticated equipment is packed into a spacecraft that, despite its large solar panels, has a main body not much bigger than an SUV. What makes these instruments particularly remarkable is that they were designed to operate in an environment no human technology had ever encountered before. Engineers had to rely on complex simulations and their best educated guesses about conditions around Jupiter. The success of these instruments is a testament to human ingenuity and our ability to explore even the most extreme environments in our cosmic neighborhood. Now let's dive into the truly mind-blowing part of the Juno mission, the discoveries that have left scientists around the world absolutely stunned. You see, for decades, we thought we understood Jupiter fairly well. Countless textbooks had been written about its composition and structure. But Juno showed us just how wrong we were. And that's what makes science so exciting. Perhaps the most fundamental revelation concerns Jupiter's core. For generations, planetary scientists had confidently taught that Jupiter had a dense, solid core of heavy elements, similar to Earth but much larger. Well, Juno completely shattered this model. Its sensitive gravity measurements revealed something nobody expected. Jupiter's core is actually diluted and fuzzy, with heavy elements mixed throughout a much larger region than anticipated. It's as if instead of finding a stone at the center of a peach, we discovered the pit material was mysteriously spread throughout the fruit. This single discovery is forcing scientists to rewrite their theories about how gas giants form and evolve. The implications extend far beyond Jupiter to our understanding of similar planets orbiting other stars. Then there are Jupiter's auroras, those magnificent light shows that make Earth's northern lights look like a candle next to a bonfire. While we knew Jupiter had auroras, Juno revealed they are the most powerful in the entire solar system, hundreds of times more energetic than Earth's. What's particularly fascinating is how these auroras are generated. On Earth, auroras occur when solar particles interact with our magnetic field. But Jupiter creates its own auroral particles by pulling material from its volcanic moon, Io, creating a complex plasma interaction unlike anything seen on our home planet. Juno captured not only stunning images of these light displays, but also recorded their radio emissions, effectively letting us hear Jupiter's auroras for the first time. Speaking of visual wonders, one of Juno's most breathtaking discoveries came when it first peered down at Jupiter's poles, something no spacecraft had ever done before. What the Juno cam revealed astonished everyone. Massive cyclones arranged in perfect geometric patterns. At the North Pole, 8 massive storms surround a central cyclone in an octagonal formation, while the South Pole features 5 storms in a pentagonal arrangement. These massive tempests, each the size of the continental United States, have remained in these precise formations for years, defying our understanding of fluid dynamics. Scientists are still scratching their heads, wondering what mysterious forces maintain these perfect storm patterns on a planet known for its chaotic weather. Finally, Juno's magnetometers revealed that Jupiter's magnetic field is far more complex and irregular than anyone had predicted. Unlike Earth's relatively simple dipole magnetic field, Jupiter's is lumpy, asymmetrical, and has regions of unusual strength in the northern hemisphere. This bizarre magnetic configuration suggests something fundamental about Jupiter's interior is dramatically different from our previous models. Even more astonishingly, Juno discovered that Jupiter's magnetic field is changing over time, a process known as secular variation that scientists didn't expect to detect during the mission's relatively short duration. Each of these discoveries doesn't just add to our knowledge, they fundamentally transform it. The Jupiter we thought we knew from Earth-based observations and previous flybys has been replaced with a far stranger, more dynamic, and more complex world. And remember, Juno is still orbiting Jupiter right now, sending back new data with each pass. The story of Jupiter's secrets is still being written. If you're enjoying this content, please hit the like button on this video and tell me in the comments, which discovery from Juno surprised you the most? And don't forget to subscribe to the Exploring the Universe channel for more fascinating journeys through astronomy and space exploration. Let's explore some truly mind-blowing facts about Jupiter that the Juno mission has revealed. These discoveries aren't just scientifically significant, they're absolutely fascinating windows into the extreme nature of our solar system's gentle giant. First, let's talk about radiation. And Jupiter is an absolute monster in this department. The radiation environment around Jupiter is so incredibly hostile that it would quickly prove lethal to any human astronaut foolish enough to venture there unprotected. To give you a sense of just how intense we're talking, during each orbit around Jupiter, the Juno spacecraft is bombarded by radiation equivalent to 100 million dental X-rays. That's why the engineers had to design that special titanium vault we discussed earlier. In fact, mission planners knew from the beginning that Juno would be fighting a losing battle against this radiation. Even with its protective shielding, the spacecraft's electronics are gradually degrading with each orbit. It's a bit like watching an explorer slowly but inevitably succumb to the elements. Except in this case, the elements are subatomic particles moving at nearly the speed of light. The radiation is so intense that even the images from Juno Cam show occasional white speckles, evidence of high-energy particles striking the camera sensor at the moment of exposure. Next, let's dive into Jupiter's incredible winds. While Earth's most fearsome hurricanes might reach speeds around 200 kilometers per hour, they're gentle breezes compared to what's happening on Jupiter. The gas giant's jet streams can reach a mind-boggling 600 kilometers per hour. Imagine winds 3 times stronger than the most powerful hurricanes on Earth, but spanning distances wider than our entire planet and lasting not for days, but for centuries. The energy driving these monstrous winds comes from a combination of Jupiter's internal heat and its rapid rotation. A day on Jupiter is just 10 hours long, despite the planet being 11 times wider than Earth. This creates weather patterns that dwarf anything in our earthly experience. What's particularly fascinating is that these winds vary dramatically with latitude, creating the distinct banded appearance that makes Jupiter so recognizable even through a small telescope. Perhaps Jupiter's most famous feature is the Great Red Spot, that enormous storm that could swallow Earth whole with room to spare. While we've known about this massive storm since the 17th century, when astronomers first spotted it through primitive telescopes, Juno has revealed something unexpected about its structure. The Great Red Spot isn't just a surface feature. It extends much deeper into Jupiter's atmosphere than scientists previously thought. Juno's microwave radiometer showed that this mammoth storm reaches down about 300 kilometers below the cloud tops. That's like having a hurricane on Earth that extends from the ground all the way up to the International Space Station. This discovery suggests the storm is powered by energy sources far below Jupiter's visible clouds, which might explain why it has persisted for hundreds of years, while Earth's strongest storms dissipate within weeks. Finally, Juno has revealed something particularly beautiful about Jupiter's atmosphere. It contains floating crystals of ammonia. High in Jupiter's atmosphere, where temperatures plunge to minus 70 degrees Celsius, ammonia gas freezes into delicate, snowflake-like crystals. These ammonia snow crystals create some of the white clouds we see in Jupiter's upper atmosphere. What's fascinating is that Juno detected these crystals being carried aloft by powerful updrafts, similar to how water vapor rises to form clouds on Earth, but in a much more alien environment. The discovery of these ammonia snowstorms helps explain some of the complex weather patterns we observe on Jupiter. Even more incredibly, scientists believe that deeper in Jupiter's atmosphere, there may be regions where it literally rains liquid metals like iron and nickel, a weather forecast truly beyond our earthly experience. Each of these discoveries reminds us that Jupiter is not just bigger than Earth. It's fundamentally different in almost every way. It's a world of extremes that challenges our imagination and expands our understanding of what's possible in our cosmic neighborhood. When the brightest minds in planetary science are left speechless by a mission's results, you know something truly remarkable is happening. The scientists who have dedicated their careers to studying Jupiter are now finding themselves rewriting textbooks based on Juno's findings. Let's hear what some of these leading experts have to say about this groundbreaking mission. Dr. Scott Bolton, Juno's principal investigator from the Southwest Research Institute, puts it plainly. Juno has shown us a Jupiter that nobody expected. Coming from the mission's lead scientist, this statement speaks volumes. I had the privilege of attending a conference where Dr. Bolton presented some of Juno's early results. The excitement in his voice was palpable as he described how nearly every measurement contradicted previous models. During one particularly memorable moment, he displayed side-by-side images of Jupiter's poles and admitted, "When we first saw these cyclones arranged in perfect polygons, we thought there must be something wrong with the camera." It's not often you hear a scientist of his caliber admitting complete surprise. Dr. Bolton later explained that these unexpected findings are precisely what make Juno so valuable. It's forcing scientists to reconsider fundamental theories about gas giants that had remained unchallenged for decades. Dr. Fran Bagenal, a planetary scientist from the University of Colorado and Juno Mission team member, focuses on another revolutionary aspect. The discoveries about the magnetic field have changed our understanding of giant planets. Before Juno, scientists believed gas giants would have relatively uniform, Earth-like magnetic fields. Instead, Juno discovered Jupiter's field is wildly irregular, with intensities that vary dramatically across different regions of the planet. In a fascinating interview, Dr. Bagenal explained that this irregularity suggests Jupiter's internal dynamo, the mechanism generating its magnetic field, operates much closer to the surface than previously thought. "It's as if we've been studying a completely different planet all these years," she remarked during a NASA press briefing. Dr. Bagenal, who has studied planetary magnetospheres since the Voyager missions in the 1970s, admitted that Juno's findings have made her reconsider theories she's taught to students for decades. Dr. Steve Levin, Juno project scientist at NASA's Jet Propulsion Laboratory, focuses on another aspect that has astonished researchers. The complexity of the Jovian atmosphere exceeded all expectations. Dr. Levin has been particularly fascinated by Juno's observations of Jupiter's weather systems. In an illuminating podcast interview, he explained how scientists previously believed Jupiter's colorful bands were relatively shallow features. Juno has revealed they extend hundreds of kilometers into the atmosphere, driven by complex interactions between temperature, pressure, and Jupiter's rapid rotation. During a public lecture that went viral among astronomy enthusiasts, Dr. Levin displayed a stunning time-lapse of cloud movements near Jupiter's south pole and commented, "We're seeing fluid dynamics that simply don't exist on Earth. It's like discovering a new branch of physics right in our cosmic backyard." And what makes these expert reactions particularly significant is the scientific humility they demonstrate. These are not researchers making incremental advances in well-established theories. They're pioneers confronting evidence that contradicts decades of scientific consensus. The excitement in their voices and words reflects the purest form of scientific discovery, the thrill of finding out that nature is even more surprising and complex than we imagined. As Dr. Bolton said in a recent interview, "The greatest scientific breakthroughs don't give us answers, they give us better questions." And Juno has certainly delivered plenty of those. The ripples from Juno's discoveries extend far beyond Jupiter itself, fundamentally transforming multiple fields of science. What started as a mission to study a single planet has evolved into a catalyst for scientific revolutions across astronomy, planetary science, and even our search for life beyond Earth. Let's start with perhaps the most profound impact, our understanding of planetary formation. For decades, the standard model suggested that gas giants like Jupiter formed with solid cores, chunks of rock and ice that gradually attracted gas from the early solar nebula. It was a neat, tidy theory that appeared in countless astronomy textbooks. Then Juno arrived at Jupiter and effectively tore those pages out. By precisely mapping Jupiter's gravitational field, Juno revealed something shocking. Instead of a compact, solid core, Jupiter has a diffuse, fuzzy center region where heavy elements mix gradually with hydrogen and helium. This single discovery has sent astrophysicists back to their drawing boards, reimagining how the largest planets in our solar system, and by extension, similar worlds around other stars, came into existence. Some researchers now suggest that a massive impact early in Jupiter's history might have shattered its original core, while others propose entirely new formation mechanisms. What's particularly fascinating is that this scientific upheaval comes just as we're discovering thousands of exoplanets around other stars, many resembling Jupiter. Juno has essentially given us new glasses through which to view these distant worlds. The revelations about Jupiter's atmospheric dynamics have been equally revolutionary. Before Juno, our understanding of gas giant weather was largely theoretical, based on distant observations and limited data from previous flybys. Juno's detailed measurements have transformed this fuzzy picture into crystal clarity. The spacecraft discovered that Jupiter's iconic bands extend far deeper into the planet than previously thought, hundreds of kilometers beneath the visible cloud tops. These aren't surface features, but massive three-dimensional structures driven by complex interactions between temperature, pressure, and Jupiter's rapid rotation. Perhaps most surprising was the discovery of enormous cyclones at Jupiter's poles, arranged in perfect geometric patterns that have remained stable for years. This violates our understanding of fluid dynamics based on Earth's atmosphere, suggesting there are fundamental atmospheric processes we've yet to comprehend. Climate scientists on Earth are now examining these findings for insights that might improve our models of Earth's atmosphere and help us better understand our own changing climate. In terms of technological advancement, Juno has pioneered innovations that will benefit space exploration for generations. The mission's use of solar power at Jupiter's distance from the Sun was considered nearly impossible before Juno proved it could work. This breakthrough has opened new possibilities for solar-powered missions to the outer solar system, potentially reducing reliance on limited plutonium supplies used in radioisotope generators. Additionally, the radiation-hardened electronics and innovative titanium vault design have established new standards for protecting sensitive equipment in harsh environments. These technologies have immediate applications for future missions, including NASA's Europa Clipper, which will study Jupiter's ice-covered moon. Perhaps most impressively, Juno's precise orbital maneuvers have demonstrated new techniques for navigating around a planet with a complex asymmetric gravitational field, capabilities that will be essential for future missions to giant planets. Finally, Juno has provided unexpected insights related to one of humanity's most profound questions. Are we alone in the universe? While Juno's primary mission focuses on Jupiter itself, its observations have yielded valuable data about Jupiter's moons, particularly Europa and Ganymede. Both moons are known to harbor vast oceans beneath their icy surfaces, oceans that contain more water than all of Earth's oceans combined. Juno's measurements of Jupiter's magnetic field have revealed how these fields interact with the moons, confirming the presence of electrically conductive subsurface oceans. During a close flyby of Ganymede in 2021, Juno directly detected changes in radio signals that passed through the moon's ionosphere, providing new evidence about its atmosphere and surface composition. These findings are shaping plans for future missions specifically designed to assess the habitability of these ocean worlds. The possibility that life might exist in these subsurface oceans, completely independent from Earth life, represents one of the most tantalizing prospects in our cosmic neighborhood. What makes Juno's scientific impact truly remarkable is how it connects seemingly disparate fields. A mission designed primarily to study planetary structure and atmospheric dynamics has ended up influencing our understanding of magnetic fields, planetary formation, astrobiology, and even practical space technology. This cross-disciplinary impact embodies the very essence of planetary exploration. By studying worlds beyond our own, we gain insights that transform our understanding of the entire cosmic neighborhood we call home. The greatest revelation from Juno was showing us that even our giant neighbor, studied for centuries, still holds fundamental secrets. Jupiter, that colossal gas giant that has fascinated astronomers since Galileo first pointed his telescope skyward in the 17th century, continues to surprise us at every turn. Each new orbit of Juno around Jupiter brings discoveries that revolutionize our understanding not just of Jupiter itself, but of our entire solar system. Think about that for a moment. A planet we've been observing for over 400 years is still revealing entirely new aspects of itself. When Juno peered beneath Jupiter's swirling cloud tops, it didn't find what scientists had predicted. Instead of a solid, compact core, it discovered something far more diffuse and extended, almost like a diluted core spreading through the planet's interior. This single finding has forced planetary scientists to completely rethink their models of how gas giants form. Then, there are the polar regions. No human had ever seen Jupiter's poles until Juno arrived. What did we find? Mesmerizing geometric formations of cyclones, arranged in perfect polygons that somehow remain stable over years. 8 cyclones surrounding a central storm at the North Pole, and 5 doing the same at the South Pole. These massive storms, each larger than our entire Earth, dance in formation with a precision that defies our understanding of fluid dynamics. And the magnetic field, my goodness! Scientists expected to find something similar to Earth's magnetic field, just larger. Instead, Juno revealed a magnetic environment so complex, so utterly chaotic in some regions while perfectly ordered in others, that it's forced a complete rewrite of our magnetic field theories. Perhaps most thrilling is how these revelations ripple outward in our understanding. If Jupiter formed differently than we thought, what about Saturn, Neptune, Uranus? What about the thousands of exoplanets we've discovered orbiting distant stars? The implications extend throughout our cosmic neighborhood and beyond. This is the true wonder of space exploration, not just answering our existing questions, but revealing questions we never knew to ask. Jupiter, despite being in our planetary backyard, remains as mysterious and awe-inspiring as the farthest galaxies. And with each pass of Juno, with each new piece of data transmitted across the void, we edge closer to understanding the magnificent world that has captivated human imagination since we first looked up at the night sky. Understanding Jupiter means understanding our own origins. When we look up at that bright point of light in the night sky, we're not just observing a distant world, we're looking at the architect of our very existence. Jupiter was the first planet to form in our solar system, emerging from the primordial disk of gas and dust surrounding our young sun over 4.5 billion years ago. As this infant giant grew, its immense gravitational pull became like a cosmic conductor, orchestrating the symphony of material that would eventually become the planets we know today, including our home, Earth. Think about this. Ancient civilizations knew nothing of Jupiter's true nature, yet they recognized its importance. The Romans named it after their king of gods, while the Greeks called it Zeus. The Babylonians knew it as Marduk, and ancient Chinese astronomers termed it the year star. And across cultures and throughout human history, this wandering light in our sky commanded attention and reverence. What these ancient sky watchers couldn't know was that Jupiter was playing a dual role in our cosmic story. On one hand, its massive gravity helped clear the early solar system of debris, flinging some comets and asteroids out into deep space, a celestial bouncer keeping our neighborhood safer. On the other hand, it occasionally redirects objects inward, some of which may have delivered water to the early Earth, potentially seeding the very conditions that allowed life to emerge. Jupiter is also why our solar system looks the way it does. Had it migrated closer to the Sun during its formation, as many gas giants around other stars have done, it might have disrupted Earth's orbit or even prevented our planet from forming altogether. Instead, it settled into a stable orbit that allowed the inner rocky planets to develop in peace. When Galileo first pointed his telescope at Jupiter in 1610 and discovered its 4 largest moons, he didn't just find satellites, he found evidence that would help overturn 2,000 years of astronomical thinking. These moons, orbiting something other than Earth, delivered a powerful blow to the geocentric model of the universe that had dominated Western thought since the time of Aristotle. So when we study Jupiter through missions like Juno, we're not just satisfying scientific curiosity, we're piecing together our own origin story. Every insight into Jupiter's structure, composition, and behavior gives us clues about the conditions that shaped our world and made human existence possible. Jupiter isn't just our giant neighbor, it's our ancient guardian, our cosmic parent, and our key to understanding how we came to be. In many ways, when we look at Jupiter, we're looking at a reflection of our own cosmic heritage. As we speak, Juno continues its breathtaking dance around Jupiter, proving with each orbit that space exploration truly represents one of humanity's greatest adventures. This remarkable spacecraft, built by human hands and human minds, is still operating in one of the most hostile environments imaginable, bathed in radiation that would destroy most electronic equipment in minutes. The mission was originally planned to end in 2016 after just a handful of orbits, but Juno has proven so resilient, so valuable, that NASA has extended its mission multiple times. Now, every 43 days, it completes another orbit, diving between Jupiter's clouds and its intense radiation belts, capturing data that streams back to Earth at a mere 140 kilobits per second. Slower than the internet connections many of us used in the 1990s. Yet each precious bit of this data forms another piece of the cosmic puzzle, another clue that helps us understand not just Jupiter, but our place in the universe. When we gaze at the stunning images Juno sends back, those swirling storms, those mesmerizing cloud bands, we're looking at processes that have been unfolding for billions of years, long before humans even existed to witness them. There's something profoundly humbling about that perspective. We are tiny beings on a small planet, yet we've managed to build machines that can travel across the solar system and send back stories from worlds we may never personally visit. This is the essence of exploration, reaching beyond our immediate surroundings to satisfy that fundamental human curiosity about what lies beyond the horizon. And the story isn't over. As Juno continues to orbit Jupiter, who knows what new mysteries it will uncover, what fundamental assumptions it might challenge next. This is science at its most thrilling, not a dry collection of facts, but a living, evolving narrative that changes with each new discovery. If you've enjoyed this journey to Jupiter through the eyes of Juno, don't forget to subscribe to Exploring the Universe channel. Hit that notification bell so you never miss new content about our fascinating cosmos. Leave your like on this video if you've learned something new today, and please share it with friends who might also be curious about our solar system neighbors. Together, let's continue exploring the greatest frontier of all, the universe itself. Remember, every time you look up at that bright point in the night sky that is Jupiter, you're now seeing it with new eyes. Eyes informed by the revolutionary discoveries of a spacecraft named after a Roman goddess who could see through clouds. And in that connection between ancient mythology and modern technology lies the beautiful continuity of human curiosity that has driven us forward for thousands of years and will continue to do so for thousands more.